Good morning, math enthusiasts. Today, we are going to discuss proving triangle congruence using some problems from the book of Geometry by Moise and Down. Example number 1. Suppose that we are given that angle TPM is congruent to angle TQN. Angle PTM is congruent to angle QTN. And the points M, N, and T are midpoints of segments ST, RT, and PQ respectively. Prove that angle RST is congruent to angle SRT. Let's start from the very beginning again. We were given that angle TPM and angle TQN are congruent. We were also given that angle PTM is congruent to angle Q2N. Also, we were given that points M, N, and T are midpoints of segments ST, RT, and PQ respectively. Now notice here that in the markings, we do not assume yet that ST and RT are congruent because it was not given. So we mark these segments differently, assuming that SM is not congruent to RN, and so do with MT and NT. Of course, also, PT and TQ, or PQ as a whole, is not congruent to any of these two. Prove that angle RST is congruent to angle SRT. Now, how are we going to prove that angle RST is congruent to SRT? Now, notice that these two angles could possibly be congruent if we can prove that ST and RT are congruent by isosceles triangle theorem. Now, in the previous slide, we assumed that ST and RT are not congruent. Is it possible that we can make ST and RT congruent? Now look into these two triangles here. As you can see, we can make these two triangles congruent because there are already three corresponding parts that are congruent. Angle, side angle, or ASA postulate. So since these two triangles are congruent, then we can also say that MT and NT are congruent by CP/CTC. So this time, these segments are no longer different, or meaning these segments are now congruent. Now, from the previous concept of midpoint, then we can also say that SM is equal to MT, also equal to NT, and also equal to RN. So what is the consequence of this concept or idea? So if SM is equal to MT, which is also equal to NT and equal to RN, then if we add up SM and MT and RN and NT, then we can say that ST and RT are equal. Okay? So, let us now create the formal two-column proof. So, statement 1 is the first given. Angle TPM is congruent to angle TQN. And statement 2 is also another given. Angle PTM is congruent to angle QTN. Statement 3 is also another given. M, N, and T are midpoints of segments ST, RT, and PQ respectively. Statement 4 is the consequence of statement 3. So we can say that line segment SM is congruent to line segment MT, line segment RN is congruent to line segment NT, and line segment PT is congruent to line segment TQ by the definition of a midpoint. Now, statement 5 is these two triangles. Referring to these two triangles. So triangle PTM is congruent to triangle QTN by the 1, 2, and 4 as a postulate. Statement 6. MT is congruent to NT by CPCTC or CSCTC. Statement 7. SM plus MT is equal to ST and RN plus NT is equal to RT, or let's say line segment SM plus line segment MT is equal to line segment ST, and line segment RN plus line segment NT is equal to line segment RT by addition property. Statement 8. Line segment ST is congruent to line segment RT by the 4, 6, and 7 transitivity or transitive property. Finally, our conclusion is arrived at. Angle RST is congruent to angle SRT by the isosceles triangle theorem. QED. Example number 2. Suppose that we are given the triangle PQR is isosceles. The bisector of a base angle, angle Q, intersects the opposite side at S, and T is a point on base PQ such that ST equals PT, and finally line segment SV bisects angle PST. Prove that angle TSV is congruent to angle RQS. Okay, let's do it one at a time. Triangle PQR is isosceles. So triangle PQR is isosceles. Then it must tell us that line segment PR is congruent to line segment RQ. Or, since we can see from the given that this does not contain the line segment symbol and the congruence symbol, it only uses the equal sign, so we shall be following that notation. So we can say that RP is equal to RQ and not line segment RP congruent to line segment RQ. So notice that in the first example, I already introduced to you that way of writing equivalence of two line segments or two sides. Okay, so again, RP is equal to RQ. The bisector of a base angle, angle Q, intersects the opposite side at S. So the bisector is actually SQ, and it bisects angle Q. So what is the consequence of that statement? That RQS, angle RQS, is congruent to angle PQS. T is a point on base PQ such that ST equals PT. So ST equals PT. What is the consequence of that? So as you can see, this belongs to a triangle. So another given, line segment SV bisects angle PST. Line segment SV bisects angle PST. So it implies that angle PSV is congruent to angle TSV. We need to prove that angle TSV is congruent to angle RQS. How could we possibly make these two angles here that are not related with one another yet to be congruent? Okay, so this is quite confusing, right? Now, let's go back to the isosceles triangle theorem. So notice that these two sides here of the isosceles triangle are congruent, and usually the implication of that or the consequence of that is that angle RQP is congruent to angle RPQ. Also, notice, if you can remember, that ST is equal to PT. And what is the consequence of that? So using the isosceles triangle theorem, we can say that SPT is equal to PST. Now look at the relationships of these three. If this angle is congruent to this angle, and this angle is congruent to this angle, then what can you say about these angles? Yes, these angles must be congruent. By the way, when I say angle RPQ and angle SPT, we are actually referring to the same angle, angle P. Angle P is being shared by these two labels, angle RPQ and angle SPT, but still, these are the same, or of course, it's congruent to itself. So that's the angle P that we are referring to. So again, let's go back. If this angle is congruent to this angle and this angle is congruent to this angle, then by transitive property, this angle must be congruent to this angle. Now, what is this angle in relation to this angle? And what is this angle in relation to this angle? So remember in the previous statements on the concept of bisect, bisector. So when we say bisect, it means it divides an angle into two equal parts. So this means that this angle must be congruent to this angle. And also, bisect again, this angle must be equal to this angle. So these two congruent angles were actually divided into two parts. And these parts must be congruent by transitive property again. So let's formalize the proof. I know it's quite confusing, but let us try to arrange our statements and reasons in a flow that you can understand better. Statement 1. Triangle PQR is isosceles, given. Of course, the implication or the consequence of that is PR is equal to RQ by the definition of an isosceles triangle. And by the isosceles triangle theorem, angle RPQ is congruent to angle RQP. These two angles. We were given that T is a point on base line segment PQ such that ST is equal to PT. The consequence of that is statement number 5. Angle SPT is congruent to angle PST by the isosceles triangle theorem. So since these two angles are congruent and these two angles are congruent, then by transitive property of statements 3 and 5, angle RQP is congruent to angle PST. Statement 7 is another given. The bisector of angle Q intersects the opposite side at S. Statement 8 is a consequence of statement 7. Angle RQS is congruent to angle PQS by the definition of an angle bisector. Taking another given, line segment SB bisects angle PST. Statement 10 is a consequence of statement 9. Angle PSV is congruent to angle TSV by the definition of bisect. Finally, our conclusion is arrived at angle TSV is congruent to angle RQS by statements 6, 8, and 10 using transitivity or transitive property. QED. Example number 3. Suppose that we are given the triangle CFG is isosceles, CD is equal to CE, and D and E are midpoints of AC and BC respectively. Prove that, first, DK is equal to EK and triangle AMB is isosceles. So this problem is quite challenging. More challenging than the first two. Let's start. We were given that triangle CFG is isosceles. Of course, the implication of that statement is that line segment CF is congruent to line segment CG. Now notice in the given that it is again using the equal symbol and not the congruence notation. So we shall state CF is equal to CG. We were also given that CD is equal to CE. And we were also given that D and E are midpoints of AC and BC respectively. So it means that CD must be equal to DA and CE must be equal to EB. Now how can we prove that DK is equal to DK is equal to EK and AMB is isosceles? So let's take it one at a time. So let's start from this portion here. Now how can we prove that DK is congruent or equal to KE or EK? Now notice that if you look at this triangle and these two triangles, by geometric intuition, these two triangles can be made to be congruent. Why do we need to make these two triangles congruent? Because as you can see, DG and FE are contained in these two triangles. Now these two triangles can be congruent because there are already two corresponding parts. The CD, the CF, the CG, the CE. So we need only one more part, and that could be the common angle. The common angle is angle C, and this angle C can be congruent to itself by reflexive property. And if that happens, these two triangles are now congruent by the SAS postulate: side, angle, side, side, angle, side. So since these two triangles are already congruent, then it's by CP/CTC, DG and FE are now congruent. But our problem is we are to prove only DK and KE or EK. How can we prove KG and KF to be congruent? Okay, so let's look deeper into these two triangles. As you can see, if these two sides are congruent, then by isosceles triangle theorem, these two angles must be congruent. Now, why is it necessary? Because these two lines, FK and KG, or line segments FK and KG, can be proved to be congruent if we can prove that these two angles here are congruent. And that is by the converse of the isosceles triangle theorem. Now, how can we make these two angles congruent? That is, if we can prove that if these two angles are congruent and these two angles are congruent, by subtraction property, these two angles are congruent. Okay. So let's do that. So again, these angles are now congruent. Now, can these angles be congruent? Yes, because these are actually corresponding parts of these two triangles. So by CACTC, CPCTC, then these two angles must be congruent. So since these two angles are congruent and these two angles are congruent, then by subtraction property, these two angles now are congruent. And since these two angles are now, then these line segments FK and GK are now congruent. Now, what will happen if these are now congruent? Well, of course, we have already proven before that DG and EF are congruent. So, by subtraction property, we can say that DK and EK are now congruent. Okay, let's start with our formal proof. But of course, it's the partial part of the proof because we still have to prove the other item here. But let's do it one at a time so that you can still recall what we have discussed previously. Statement 1, triangle CFG is isosceles. That was given. And the consequence of this given is that CF and CG are equal, or CF is equal to CG by the definition of an isosceles triangle. Another consequence for number 2 is statement 3. Angle CFG is congruent to angle CGF by isosceles triangle theorem. Now, CD and CE are given to be equal. Statement 5. Angle C and angle C are congruent to itself, or angle C is congruent to angle C by reflexive property. And statement 6. Triangle CDG is congruent to triangle CEF by 2, 4, and 5. SAS postulate. Statement 7. DG is equal to EF by CPCTC. This one. And angle CFE is congruent to angle CGD by CPCTC or CACTC. This one. And angle GFK is congruent to angle FGK by the subtraction property using statements 3 and 8. Statement 10. FK is equal to GK by the converse of the isosceles triangle theorem. And finally, DK is equal to EK because of the subtraction property made in statements 7 and 10. To be continued because we will discuss first how we are going to prove item letter B. Now, from our previous discussion that CD and DA are equal, CE and EB are equal, and also CD and CE are equal, then if we add these segments and add these segments also, their sum must be equal. So we can say that AC and BC are equal. Now, if these sides are equal, then by the isosceles triangle theorem, we can say that angle CAB is congruent to angle CBA. Now, in our previous discussion, we were focused on these triangles. But since we are looking into this part already, then let's expand our vision, or let's expand Let's expand our observation with regards to the triangles here. So we can look into the bigger triangle. Can you see that? So triangle CAE and triangle CBD. Again, can we make these two bigger triangles congruent? Yes, because we have a common angle. We have this part, which were already found to be congruent, actually given. And these parts, which we found to be congruent recently. So, these two triangles are congruent by the SAS postulate. Then, we can say that AE and BD are congruent by CS-CTC if we wanted to prove that these are congruent. But I think it's difficult for us to prove that ME and MD are congruent. So, we look at another option. Now, if you notice, these angles are parts of these two bigger triangles. So, by CACTC or CPCTC, angle C BD and angle CAE are congruent. Previously, we have also found that these are congruent. So what can we say about these angles here? Okay, so these angles are congruent by subtraction property. That means bigger minus smaller, and of course, corresponding parts that are congruent. Then our leftover here, these angles are congruent. Now, what is this in relation to this? Well, of course, these are the base angles. And since these base angles are congruent, then line segments AM and BM must be congruent by the converse of the isosceles triangle theorem. Let us now continue with our formal proof. Notice that this given was not included in our previous statements. It is because our focus was only on these two triangles, and it is not the idea of AD and BE are not important yet. And so I reserve this given for this portion here. So D and E are midpoints of line segments AC and BC respectively, which was given. Then, statement number 13 is the consequence of statement 12. So CD is equal to DA and CE is equal to EB by the definition of a midpoint. And, as I have mentioned, you need to add these segments. So AD plus DC is equal to AC and BE plus EC is equal to BC by addition property. And as I've also mentioned, their sum are equal. So statement 15, AC is equal to BC by transitivity of statements 4 in the previous proof, then 13, then 14. Statement 16, angle CAB is congruent to angle CBA. These angles are congruent by the isosceles triangle theorem. Then, triangle CAE and triangle CBD, the two bigger triangles that I was mentioning a while ago, are congruent by SAS postulate by considering statements 4 and 5 in the previous slides and 15. Statement 18, angle CAE is congruent to angle CBD by CPCTC or CACTC. Statement 19, angle MAB is congruent to angle MBA by the subtraction property using statements 16 and 18. Statement 20, AM is equal to MB by the converse of the isosceles triangle theorem. Finally, we have arrived at letter B of our conclusion. Triangle AMB is isosceles by the definition of an isosceles triangle, QED. Proving geometrical statements does not only require intelligence and correct reasoning. It also requires patience and determination. Full concentration, optimism, and organized thought are also important to be successful in this area of learning. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!